should be going live. Testing. It is almost 6:25.
Vou ter que dar um banho no cara, tá fedendo.
That was a thing. Okay, so let's get this started. Ooh, okay. So, to whoever's going to be watching this in the future, what I'm going to be doing is I'm going to be doing some low-level Rust programming. Why? Because I've taught myself how to program in Rust. I feel like I know how to use it. I know how to actually work with the compiler and not feel restrained by it. And I want to put that into practice. I want to be able to actually see if like what I know and what I believe I know can actually be put into practice and be used to make something, because professionally I do not work in Rust. Rust is not something that I use in my day-to-day. It's something that I saw and I wanted to learn because I've used C, although I also haven't used C professionally, unless like you count some things we've done like when I was in school. I mean, like only students have paid me to write C, not actual companies yet. Companies have asked me to write a lot of other things, so like Java, Ruby, PHP, JavaScript. I've been around the block. I know how to do a lot of things in that regard in regards to programming. But I was very interested in Rust because all the low-level things that I am able to do in C, I can also do in Rust. But I also don't have to deal with like C's old age, because we gotta be honest with ourselves, like C is not the best experience nowadays. Yeah, there are a few like things in C11 that like made it better, but like no generics. I mean, like we got generics, but we don't really got generics. We don't have a lot of compiler generated things. Our macros are only text replacement, and all that makes a person want to move on to something more modern to be able to work with lower level applications. And so I invested my time into Rust. You can't really not like learn C though, so I also know enough C to be able to do low level and also in Rust case unsafe programming. So this is all going to be no standard Rust. No standard, for those of you who don't know, is a flag that you can activate in your library. So let me check right over here. In my source file, I have my main. Let's also create a library file. And in that library file, we're going to declare no standard. No standard is a flag that we put on a library that basically says we are not going to be using the standard library. We are only going to be using core, and if we ask for it, alloc. For those of you who don't know, Rust, let me pull up right over here. Where is it? So we have, let me pull it into view, the Rust standard library. The Rust standard library, as we can see over here, has a few top level crates. In the case of standard, like standard is just re-exports of what's in alloc and core, and then also a few like modules that are specific only to standard. So any of the platform code, which is anything that interacts with the operating system, network code as well, I/O, commands, all of those are done through standard lib. And we don't want to use those at the moment. Like, in this case, it isn't because like the standard library is bad, like in the case of C++. This is just more of a case of like, we are like Goku turning up the gravity in the chamber, and we're like putting on some restrictions to actually learn how low-level code works, because when you don't have standard enable, you lose a lot of things, and you either have to build your own implementation of those things, or you don't use them anymore. I plan to, in this case, only use libcore. Maybe I'll cheat. I'm not sure if like I'm gonna make that a hard limit. I'm gonna keep it a hard limit until like it's too annoying, but like only libcore, so no alloc, because I do not want to be bound to Russ's implementation of certain types, because I have different opinions on like what should be inside of a standard library, and Russ has given me the opportunity to also just like do whatever I want in that case. So let's go. So core is just all of the minimum Rust implementation, I guess would be the right way. Yeah, it's the minimum for Rust to be Rust. So all the primitives, all of the basic data types that aren't dependent on allocation are defined in core. And data structures that depend on memory allocation will work, so vectors, hash maps, B-tree maps, decks, all of these require alloc, which is another external crate which exports box, RC, arc, format as well. Although there is some intersection between like what's in core and what's in alloc, because like I believe in the case of alloc there's going to be some extra things that are in format that aren't in the core format module. I believe format for core only has what's necessary for you to like basically implement your own print line statement. And I guess I should probably make it clear too that like my code is gonna have to be non-standard, but like library code has to be no standard. Application code, which is gonna be everything glued together, is gonna be whatever, just for like the sake of it, for the sake of simplicity, because that's too much complexity in the moment. I think I should just like get to actually writing code and actually show what's going on. So let's see. Since we're not going to be using lib standard lib, STD, since we're not going to be making use of sexually transmitted diseases. Bleh, that was a gross thing to say. Okay, so one thing that like we gotta make use of is, since we're not going to be using standard lib, we're going to be needing some platform layer, right? So I'm on Linux. We're going to add libc. Libc enabled. I'm going to start making some small utility functions to be able to interact with memory. Let's pull in some. Okay. So we're going to define a memory block. A memory block is going to be a buffer pointer. So a pointer that points to an unsigned 1-bit integer, or 1-byte integer. So probably just like for the sake of it, let's do type byte is U8. Or should we make it, it's probably better if we do null. I believe that's what Rust I think that's what the documentation recommends. In the case of we want to like do type erasure and we don't care about what is behind this pointer until we actually cast it to something. We cast to the unit type, which is the equivalent of avoidancy. So we got a buffer pointer that's going to be pointing to somewhere in memory. We're going to get the size of that pointer, and we got the capacity. So if this is going to be like a block of memory, and we visualize that block of memory as like an assembly line, the buffer is the assembly line, the size is where we are currently at, like how many things have gone by in the assembly line, and the capacity is the total amount of things that are going to go by in that assembly line. So let's do an implementation of this memory block. I don't want the autocomplete of that because that's trash. I should probably, gotta turn off Copilot. So, where is it? Log out. Let's log out of Copilot so we don't get any suggestions right now. And now let's actually make an implementation of the system block. First, we're gonna need libc and what? Let's just pull an nmap and then like the LSP is gonna actually tell me what I need to write. So per capacity. So like with capacity, that's all. And it's gonna receive a size, and it's going to return an instant of the implementation, which is memory block. So got our memory block. We first got to allocate the buffer. We're going to be using mmap in this case. Oops. Okay. My bad then. Let me get my audio up. I'm just using the webcam at the moment, so I'm gonna see if there's like some setting I can up. Whoops. Where is it in my audio settings? Is it this? How about now? Is my audio still low? Okay. Okay. I'm not always focused on the chat, so I'll wait for you to respond. Uchukara? Okay, Uchukara. Nice to meet you. So, back to programming. We're going to be using mmap then to actually allocate. So, what are the arguments for mmap again? Oh, no. We're going to use the bad word in Rust. Let me pull up the parameters for mmap. Mmap, I think it like return, you gotta pass in a null pointer. So, core pointer null. Okay, now it's pulling up everything. So the size is gonna go in here, and we want it to be readable. Writable as well. Let me pull up chat. Sweet. Feel free to ask any questions in the chat. So, okay, so what are the other parameters? Flags. Oh, yeah, there's map, like anonymous. No file descriptor and no offset into memory. Okay, so the size is going to be 0, the starting size. The capacity is going to be the size. So there should actually be a capacity. The length is going to be capacity, and then oh, I have to actually cast this now, so or does that cast not work here? With that memory block now, so I'm going to implement drop for this memory block. And here. Okay. Yes. Probably a good time to assert what we're actually doing here, so first actually, let's put this onto a separate module. So I'm going to put this into a module called men. Let's just export everything that's public. That way, over here, as it kind of just use now, create. Let's just we run this. Is this gonna source mem? Is there anything? Yeah, I don't think there's gonna be any that prevents compile. And this is now private, so let's make this public. So if I run this now, we'll jump after this print. Everything's going smoothly now. And let's create a test, so. Let's just create a function, create a block. It's going to take the capacity as a use size. It's going to be a memory block. I don't need a separate function for that. Right, so let's just create the test. Let's test. So, let block equal memory block with capacity. It's just defining this as test capacity. I gotta think of this in type, right? Yeah. There's sent me a message. Okay. Okay, so let's actually, and then the buffer, we're going to see it as just like not being null, so. So runs, cargo test. And our test runs and passes. Great job. Okay, so now that we've created a block, let's also create some functions to allocate from it. Because in the biggest problem with anything related to level programming is making an allocation when you don't have to. You much rather would like to allocate things up front and then allocate from that block and use it as we would like instead of allocating each time that we need more code and more memory, right? So to facilitate that, I'm gonna add a few things. So let's pull in. So the target's got to be is this how I type? It should be, right? Yeah. And then it's like 2. Yeah. I know how to write a implementation of deref. Make a slice from raw parts. Let's go get our pointer. So now we can test. So actually Okay, so we're gonna assert that we already get a slice covered. So we should be able to create this slice. And the length of it's going to be the capacity, right? Let me just make the test right now. Okay, that's also passing. Now it's time for direct mute. So if we were to get them okay. Actually, this might be an interesting way to do it. So let's do this way. If I were to get let's do like int val from the block actually okay, since this is, I have to typecast this to a pointer somehow, so I guess I don't really want that. Just make it a U8. The advantages of using type balances. Okay. Now that I have ways to actually like subdivide this block of memory using since it now can be dereferenced as like a slice of bytes, I can use that to divvy it up into small allocators. We're going to be calling them arenas. It's gonna seem like redundant to make this distinction because they're gonna have the same exact signature. Like, we could do this to be like self-referential, but I prefer to have it like we have a parent structure and then the child structure, and in this case the parent is the memory block and the arenas are children of a block. They're functionally the same thing underneath, but I prefer to make that distinction just because it's easier to communicate with other people. So it's like you create a block of memory, it's 16 megabytes. 4 megabytes of that's going to be for one arena, 8 megabytes going to be for another arena, and then like we can divvy up the remaining 4 megabytes and like 1 megabyte arenas that like we can rotate or we can use as a temporary buffer. And I can say that like this block could be divvied up into these smaller blocks and they all reference this one bigger block, but it's better to have two separate names. In this case it's going to be arena, and arena is going to be created from a block, so let's define a method on our memory block that divvies up a part of itself and creates an arena from it. So an arena, actually, to make it even better, should I want this? Actually, nah, I'm gonna make it a pointer instead of being life. Do I want to? Okay, let's do some bound lifetime just for the sake of it. That'll be fun. So like we can do some. Nah, I'll have the lifetime marker there. It would be interesting that even though like we can add like the lifetime marker, so it's always gonna be in scope with the memory block. I'll say that for later. Oh, what you got it. So it's no STD just for like, for me to be able to like learn how to make a lot of these data structures from scratch. Eventually I want to be using these to make a game. That's going to be like the end goal, but at the moment I'm just making some low level tools that I'm going to be using in development. So I don't want to be dependent on what's on site or library, and I also just want to be more comfortable with unsafe Rust. So That's kind of just like the limit that I'm putting on the code that I'm going to be writing during these sessions. So like, we're not going to be using any box, vec, or if we do have those inside of the code, they're going to be our own implementations. And so right now, since we aren't using anything inside of the alloc crate, we have to make our own memory allocators. One moment, be right back, everybody. Thank you for noticing. Did you get what I said earlier about like why we're using a standard? Or was I also muted then? Yeah, that's basically it. Like, it is a vibe. It's like, just think about it as like, it's like doing exercise with weights on. It's more difficult, but like, it's better in the long run for you. Not really worried about being practical right now. Okay, I still got passing tests. And now we can create arenas from our blocks. And now we can start working on, whoops. Okay. Now we can start working on arenas. This unsafe, so unsafe. There's a pub unsafe function all parts. That's gonna get a buffer pointer, so. Okay, test are still running. We'd love to see it. Get off soon. This was just going to be a test stream to get a feel for this. But thank you for being my first viewer. We'll be back tomorrow. So, what the size? So I'm using, where is it? Because it's Ghosty running Emacs. But Ghosty's running in full screen on me here. So yeah, it's just Ghosty. I have Tmux open, and I have Tmux with my main editor being Emacs. So I just have it split and create another app over here. Build. Could like run term in here, but that'd be overkill with it. Because I'm like too much recursion. A terminal running inside of it, Emacs. A terminal running inside of Emacs, which is running inside of a terminal. And like you can just keep on going down further and further. It used to be a fun party trick where you'd be like, yo, I can run Emacs, and here's the terminal inside Emacs, and here's Emacs inside the terminal, and here's another terminal inside of Emacs, and here's Vim inside of that terminal inside of Emacs, inside of the terminal inside of Emacs. Great tail twister. Oop. So yeah, I get the current size. I use that to generate the new offset, or to get the current offset that's going to be memory aligned to what they're currently asking for. Use that to generate the new offset, and if that new offset is less than or greater to our capacity, then we can allocate. If we can't, we return none. So I can just do none. And then here, we calculate the starting address of our new allocation. So it's going to be and then we set the new offset. some. Since we know that, like, this can't possibly be null, we can just do the unchecked version. I think I just cast it too, right? Is it gonna let me? I can't deref into an arena. Should get that in order then, so. I can just copy and paste. Let's go to that. So I got an address, so I can cast this to U8, and then cast that to the point, right? I can do that. Is it because I don't know what problem with that. Would it allow me to do it on comments over here? No, it's gonna complain. And let's just add a clear function as well. Okay, so it's gonna start like that, so let's just allocate then with dummy value. Allocate 1.
precisar que você pegue o lanche, porque ela
Well, I have actual responsibilities to attend to. But thank you for watching. I'll be back tomorrow. Good night.